We all know that IBM's Spectrum scale is extraordinary, but it hasn't been able to take full advantage of NVMe SSDs. That is until now. Introducing Pavilion Data's NVMe over Fabrics storage platform. IBM named Spectrum Scale for a reason. It can scale almost infinitely simply by adding more nodes. Sharing very large capacities works great on a SAN, but scaling for speed or throughput can get expensive quickly. Pavilion Data lets Spectrum scale. We bring the power of shared storage using standard NVMe SSDs and standard NVMe over Fabrics topologies. You may not have heard of Pavilion Data just yet, but word is spreading fast in the Spectrum Scale community. A massively parallel compute center has deployed our storage array as part of a genomic sequencing cluster running analytics through more than 120 nodes with a single 4U chassis. Another customer has more than 512 nodes deployed with a few arrays. In this particular environment, the goal was to achieve the highest throughput ever for a single shared storage namespace with Spectrum Scale. The customer summed it up as making the impossible possible. Of course, it's not impossible for Spectrum Scale to set new records, but at what cost? On the left are some of the finest storage systems on the planet, with massive code bases supporting hard drive, SATA, SAS, or NVMe SSDs. They can crunch 16 million IOs a second, support up to 16 terabytes of DRAM for write caching, allowing 150 gigabytes a second of throughput. Of course, they take up a fair bit of space, power, and cooling, and can get expensive quickly. Pavilion's NVMe over Fabrics array was designed from the ground up for NVMe rack scale deployments. 2 units at 4U each can crunch 40 million IO a second, deliver 240 gigabytes a second of bandwidth at about a tenth of the cost. Of course, the most noticeable thing in this diagram is size. We call it performance density. This simple formula contrasts footprint to performance. The next time you're getting wowed by big storage vendor elevator pitch, we suggest you ask one little question. What's your performance density? Let's look under the hood. Protected by more than a dozen patents with more pending, the Pavilion platform looks a lot like a network switch. It has dual 6 terabit PCIe switch fabrics, dual management controllers, and can use any off-the-shelf NVMe drive from your favorite manufacturer. If you have a volume purchase agreement with a drive maker, just buy the drives directly. Reuse existing drives. Most importantly, don't wait for vendor refresh cycles. When the hottest new NVMe device is available, buy it and deploy it in a Pavilion platform. But how does this little box achieve such high IOPS and throughput? Really smart code designed specifically for NVMe. We have 20 line cards, each with 4 100 gigabit ports for InfiniBand or Ethernet. Each line card has 2 storage controllers that use standard Intel processors. And oh yeah, while we have some DRAM for metadata mapping, our data plane is so fast that we use 0 DRAM for write caching. Cacherless writes is one of those fundamental patents. Of course, it has all the manageability features you would expect in enterprise SAN, including RAID 6 erasure coding, snapshots, thin provisioning, encryption for data at rest, and an API for framework integration with Redfish or Swordfish, as well as a really cool feature that allows us to swarm controllers together to rebuild a failed drive. For a 2 terabyte NVMe SSD, this takes less than 5 minutes. In a large cluster, setting up shared volumes is easy. Use the GUI, CLI, or framework integration to assign NSD clients or servers to a controller. Assign that same set of hosts to another controller and voila, you have a shared NVMe SAN. Use standard NVMe over Fabrics multipathing for failover and you have resiliency. Since each Pavilion controller supports 4096 NVMe queues, it's possible to define each NSD node with 8 queues and up to 512 nodes to any given controller. But note that this isn't the same methodology that was used for making the impossible possible scenario we talked about earlier. Of course, Spectrum Scale has quotas and snapshots, so some of the enterprise features are not needed regularly. But there are scenarios where zero footprint snapshot could be useful. A good example is an export of a large source data set, say an entire cluster, from one spectrum scale to another destination cluster for analytics. Pavilion Data makes this easy. Take a snapshot, clone the image, mount the volume to a new destination set of hosts, and go. It's a snap. Just a quick recap. In this cool little array, we pack 120 gigabytes a second with 100 microsecond end-to-end latency, up to 20 active-active controllers, supporting a wide range of NVMe over Fabrics topologies. We connect to hosts with 4 100 gigabit InfiniBand or Ethernet ports per line card, taking up only 4 U, supporting any manufacturer's NVMe SSD, with up to 72 drives or about 1 petabyte of capacity with today's SSDs, all of the management features you'd expect in an enterprise SAN, and all for about 1/10 the cost of the big storage brands. So if you're looking to scale spectrum scale in AI, electronic design automation, media and entertainment, genomic sequencing, or any other workload that demands performance, look for the ultimate rack scale array, Pavilion Data Systems.